You open a website. It loads almost instantly. But in that tiny moment, something extraordinary happens. Your request doesn't just stay inside your phone or laptop. It begins a journey that can span cities, countries, even entire oceans. So what actually happens when you use the internet? Let's go behind the screens. Most people think the internet is something invisible, something wireless, something called the cloud. But the cloud is not in the sky. It's made of real machines, real cables, real buildings, and real systems, all working together every second of the day. To understand how the internet really works, follow one simple action. You type a website address and press enter. Your device doesn't understand words like websites or pages. It only understands numbers. So the very first thing your device does is ask a question. Which computer in the world owned this website? This question goes to a system called DNS, the Domain Name System. Think of DNS as the internet's global phone book. It translates human-friendly names into numerical IP addresses that computers can understand. DNS servers are spread across the world, constantly answering trillions of requests. Without DNS, the internet wouldn't slowly break. It would stop instantly. And at this point, your request still hasn't reached the website. It's only found the address. Now, the real journey begins. Your message is not sent as one piece. It's broken into tiny units called data packets. Each packet carries a small part of the message, along with instructions about where it came from and where it needs to go. This design is intentional. If one packet is lost, damaged, or delayed, the system can resend just that piece instead of everything. This is why the internet feels reliable, even when parts of it are failing. These packets now move through routers. Routers are the silent traffic managers of the internet. They don't know what your message says. They only care about one thing. Where should this packet go next? Each router makes that decision in milliseconds. There is no single fixed path. If a route is busy, slow, or broken, packets are instantly redirected through another path. Your data might take a completely different route than someone else's, even if you're both opening the same website. This flexibility is one of the internet's greatest strengths, but also one of its biggest complexities. Here's something most people never realize. Over 95% of global internet traffic travels through physical cables, not satellites. Cables, thousands of kilometers long, running underground, across cities and deep beneath the oceans. These undersea cables connect continents together. When you open a website hosted on another continent, your data often travels along the ocean floor. The internet is not wireless. It's wired across the planet. And when one of these cables is damaged by anchors, earthquakes, or accidents, entire regions can experience slowdowns or outages. Yet most users never notice, because the system quietly reroutes traffic elsewhere. Eventually, your data reaches its destination, a server, a powerful computer designed to respond to millions of requests. The server receives your packets, understands the request, and prepares a response. But again, nothing is sent back as one piece. Images, text, and videos are all broken into packets and sent back the same way. Your device receives these packets, checks if anything is missing, requests replacements if needed, and then reassembles everything in the correct order. That's the moment the page appears on your screen. What feels instant is actually a carefully coordinated process involving dozens of systems. Speed comes not from simplicity, but from design. Protocols like TCP make sure data arrives correctly. If something goes missing, it's resend. If packets arrive out of order, they're reorganized. If congestion happens, transmission speeds adjust automatically. Latency, bandwidth, and reliability are constantly balanced behind the scenes. This is why the internet works even under massive load. But this system is not perfect. Sometimes, a single human error can disrupt large parts of the internet. A misconfigured router, a faulty update, a small mistake in the wrong place. These failures don't always make headlines, because backup systems take over, but they remind us how delicate this global network really is. Every message you send, every video you watch, every website you load depends on cooperation between thousands of independent networks, companies, governments, and institutions, all running different pieces of the same system. There is no central switch, no single controller. The internet works because millions of systems agree to follow shared rules. That cooperation is what makes it powerful and fragile. The internet isn't magic. It's one of the most complex engineering achievements in human history, built layer by layer, maintained quietly, and working every second so you don't have to think about it. Now you know what's really happening behind the screens, and this is just one of the many hidden technology systems that quietly power the modern world. Welcome to Hidden Tech Systems.